So short-term and long-term behavior of polynomials. So short-term is what it seems like. It's just over the short part of the graph, or like in a short period of time when you look close to the origin. Long-term behavior is when you're looking at the entire graph. What are the ends of the graphs doing? You will always, and of course pause this if you need to keep writing that down, but as we always read it as x approaches negative infinity or positive infinity, what's happening to y. So we write this down, or you write it as x approaches. So as x is approaching negative infinity, y is approaching either positive or negative. And then x approaches positive infinity, y approaches either positive or negative. So if you look at a graph that looks like this, so if you look at this graph, as x approaches negative infinity, so you always start at the origin and move towards negative. So I'm approaching negative. So as x approaches negative infinity, what are the y values doing? So if you look, since the y values or the graph is pointing down, y is going to approach negative infinity as well. Okay, then if you look as x approaches positive infinity, so as I move this way, the graph goes up, so y approaches positive infinity as well. Okay, your leading coefficient, or the number in front of the term with the highest degree tells you what is happening. Oops, sorry, you can't even see it. So the number in front of the term with the highest degree tells you what is happening. So if I had y equals 2x cubed minus 3x plus 4, this is the leading coefficient, the 2. So just like the highest degree tells you what type of graph it's going to look like, the leading coefficient is going to tell you what to do. So we have 2x cubed minus 3x plus 4. So notice this one looks pretty much like that. It's just shifted up. When you're talking about end behavior, you don't care what's going on in the middle. You don't even need to look at it. You just need to look at the two ends. So this one, as x approaches negative infinity, y is also approaching negative infinity. And then if you look as x approaches positive infinity, y is going up. Now, I'm going to switch that leading coefficient to a negative. In order to do that on your calculator, if you hit second delete, notice how it says INS. That stands for insert. It will let you insert a negative. Remember, don't put a minus sign like this one. Put a negative out in front. And then I'm going to graph it. Notice, instead of it going up, it's now going down. So I'm going to go ahead and draw that. So if I do y equals negative 2x cubed minus 3x plus 4, and it looks like this. That's not a very good drawing, but okay, you always write it as x approaches negative infinity and as x approaches positive infinity. So as my x gets smaller and smaller this way, it's going up. So then y approaches positive infinity. Okay, now I'll look this direction as you move along the x-axis. The values are going down, so y approaches negative infinity. Finding zeros from factored form without a calculator. Remember, zeros is when the equation is equal to 0 or when your y is 0 because it hasn't moved up or down any. It's just on the x-axis. So remember, those are your zeros. So in order to find these, if I gave you this, remember this is factored form because it has the parentheses that multiply to get the information. So again, remember you set it equal to 0, and then x minus 2 squared, and x plus 1. So if I have this equation, I'm looking for when the parentheses, or what number I can plug in for x that would make this equal 0. So if you look at this, I could plug in a 2 here because 2 minus 2 would equal 0. And even if I put a 2 in here, 0 times anything, 0 times 100, 0 times 500, 0 times 1 is always 0. So you can actually have two different solutions for these just because you can plug in a number here that would make this part equal 0 and 0 times whatever, it would still give you 0. So I'm going to go ahead and plug in a 2 just to show you. So 2 plus 1 is 3. And then in your calculator, if you type in 0 times 3, it's 0. So one of your solutions is 2. And I will show you an easier way to do this so you don't have to guess. And then another solution, I want to look for when this parentheses, what number I'd plug in for x that would make this parentheses become a 0. So negative 1 plus 1 equals 0, and 0 times whatever I put in here would still be 0. So your solutions, or your zeros, are 2 and negative 1. You should have seen that when we did the entry task, that the zeros were 2 and negative 1. Okay, so if you aren't able to just look at some of these and figure out what the zeros are, you can always follow these steps. So first step, set parentheses equal to 0, and set all of them equal to 0. So I'm going to set this first one, x minus 2 equals 0, x plus 1 equals 0. Because remember, I'm trying to find what number I can plug in to make this parentheses equal 0, because 0 times anything, it doesn't matter, would give you 0. Now, there is an x minus 2 squared, so I actually have 2 of those parentheses. And that's important for what we're going to talk about in just a second. So x minus 2 equals 0 and x plus 1 equals 0. So solve like you always do. It's actually a pretty easy. So opposite of subtract 2 is add 2. Add 2. So then one of your solutions is 2. And then subtract 1, x equals negative 1. This one, of course, is going to be the same thing, but again, it's important. So x equals 2. Now, it's very important for you to notice that it's the opposite sign. If it's only a one step, like there's not a number in front of x, it's always going to be the opposite sign, because remember, instead of subtracting, you're adding. Now, I'm going to go ahead and graph this because I want to talk about, I want you to see, oh, I forgot to write the second step. Solve each equation. Sorry, wanted to write down that step. Okay, so I'm going to go ahead and graph these. X minus 2 squared and x plus 1. Now, if you notice, the type of zeros, and this is what we're about to talk about, is the types of zeros that you'll see, or types of zeros. Notice for -1, it just went straight through, and then at 2, it actually hit and then bounced off. Notice, since this was squared, we had 2 parentheses like that, so we actually have that 2 listed twice. So what we call that is multiplicity. So multiplicity, if the graph goes, oh, you can't see it, straight through, the x-axis, the multiplicity is odd. If the function bounces off the x-axis, it has even multiplicity. In the trick that I always like to use, so the trick I always like to use is if it's a 2 or even, it's going to bounce off. If it's odd or just has a multiplicity of 1, it's going to go straight through. So 1 goes straight through, 2 bounces off.